Types of relationships. Number one, we got constant ratio relationships. Consider a scenario where monthly cost of food is predicted to increase at the rate of 7.4% per year. Monthly food cost in 2011 is 3,000 rand, right? Then monthly food cost in 2012 will be 3,000 rand plus 7.4% times 3,000 rand. So here we're basically saying 7.4% of 3,000 rand, because they told us in the statement that the monthly cost of food is predicted to increase at a rate of 7.4% per year. So monthly food cost in 2012 is equal to 3,000 plus 7.4% times 3,000. Monthly food cost in 2013 is equal to 3,222 plus 7.4% times 3,222, meaning 7.4% of 3,222. Okay, so 3,222 is the answer you get from this. If you calculate this, it should give you this. Then monthly food cost in 2013 will be this plus 7.4% of that, which gives you 3.22. Okay, let me just say it the proper way. 3,222 plus 238 and 43 cents, which sums up to 3,460.43 cents and 43 cents. 43 cents. Wow. Okay. So we have the following table. Okay. We have year and we have monthly food cost. So we have year 2011, 2012, 2013, 2014, 2015, so on and so on till 2021. Then we have monthly food cost. These values here. I'd like to show you something real quick. Okay, so let's say you're asked to plot a graph. One thing you should know, if you see like something on top here, whatever these values are and whatever this is, like here we have year, this goes on the x-axis and this goes on the y-axis. Remember that always whatever's on top goes on the x-axis and what's on the bottom on the y-axis. Okay, or if you have something like this, if they give you something like this, maybe it's also food price, something like that, this will go on the x-axis, then that on the y-axis. Right, so make sure you know that. So just like here, the year is on the x-axis, this is the x-axis right there, 2011 up to 2021, and the monthly food cost is 3,000 whatever and so on is on the y-axis. Now my graph is not very accurate, but I show here, this is what you must know, that it grows exponentially. Okay, it grows exponentially because the monthly cost of food increases per year, increases, so it gets steeper and steeper because the monthly cost of food is increasing every year by another value, in fact by a constant value, so it keeps on increasing. That's why it's like this. You know, it's like the price of bread, it increases every year. Now bread is 20 rand if I'm not mistaken. Yeah, even eggs too. Eggs are hell expensive now. 4 rand for one egg. Pyramid scheme. But anyways, that's not what we're here for. So it's this shape over there, this shape over there. Okay, just know that constant ratio relationships, the graph looks like that. So don't mistake it over there, don't make a mistake there. So the value, like I said, is increased by a factor. Okay, that is, it is multiplied by an amount, like shown here. It is multiplied by an amount or a percentage. It's shown right there. You see, we have this 7.4%. We have this value there. The value here is multiplied by a percentage. Okay, so moving on to the next graph. So we have this graph, combinations of relationships. So there's our values for the x-axis, total off-peak calls in minutes, then total monthly cost. Okay, so as you can see here, 0 here, from here to I think about there. Can you see that the total monthly cost is constant? Then it starts changing there to there. Now on our graph, here is how it is shown. This is how it's shown. Okay, so we have this portion here, we have this section. Let's not call it a portion, let's call it a section. This is the flat portion. Okay, and we also have this portion over there. As you can see, this is an increase. This is an increasing portion. One thing about these two is that both of them are straight lines. They're linear. Okay, so they're both linear. It's just that this one increases and this one is just constant. Straight line here, straight line going in this direction, linear direction. That means something is constant. Something is constant, and we know that it's the total monthly cost of food. Right there, it's the total monthly cost of food, and our total off peak is the hours are the ones that change. These ones right there. Now, for this graph, the flat portion represents that there is a fixed monthly subscription fee. Okay, a fixed monthly subscription fee. Okay, that's why you see it being linear. It's fixed, so that means the price doesn't change for a certain period of time. Okay, so it is a fixed monthly subscription fee of 169, as you can see, 169 rand over there. But the contract also comes with 100 free minutes. Okay, I didn't put the statement, but it comes with 100 free minutes. For the first 100 minutes, there are no calls charged. No calls are charged for, and only the subscription fee is payable. Okay. After the 100 minutes, as you can see there, after the 100 minutes, an additional fee is payable for the calls made. As you can see now, this value now is also increasing as this value increases. Okay, so there's an additional fee payable for the calls made after the 100 minutes. From there, we see that the additional charge is 0.95 cents. If you pay attention here, from 169 to 169.95, that's plus 0.95 cents. That's 95 cents to be exact. Then represented by an increasing portion of the graph. So this is represented by an increasing portion of the graph. This change that happens there, the additional fee that is paid here, it is represented by the increasing portion of the graph. Moving on to step functions. So same thing for step functions. I didn't really put much. I didn't put the statement, but just put the table over there because I didn't think that it's really necessary to put it. So here we have our time in minutes, tariff brands. So here we have less than 1 hour, 1 to 2 hours, 2 to 3 hours, 4+ hours. Okay, 1 rand, 5 rand, 9 rand, 15 rand. Okay, so for this one, it's a step function because as you can see, form steps here, steps. Okay, so for this one, it indicates fees charged for different time intervals, as you can see here. Okay, less than 1 hour, that's less than 1 hour there. Oh, it's less than 1 hour, right? Less than 1 hour is about 60 minutes. So as you can see, my graph is not that up to scale, so it should be somewhere there. That's 1 rand, right? That's one time interval. Then we move on to the next step. Next step is 1 to 2 hours. 1 to 2 hours for what? 5 rand. So that's 5 rand there. 1 to 2 hours is from 60. Okay, so that means we are supposed to be somewhere there. To 120 somewhere there. Okay. So that's how you draw this. It's different fee is charged for different time intervals, as you can see there. 1 to 2 hours is here somewhere there, it's from 60 to 120. Okay, because that makes 2 hours. 60 plus 60, that's 120, which makes up 2 hours, which is 1 to 2 hours. Then we move on 2 to 3 hours. You can see indicated here at 9. Obviously 2 to 3 hours, it's beginning to 120 to 240. So here we'll be estimating points of intersection of two graphs from a graph. Okay. Comparison of postpaid versus prepaid electricity. As you can see, the borderline the borderline is prepaid. So prepaid is represented by the borderline there, and postpaid is represented by this dashed line. So we have our graph, and we want to determine the point of intersection using equations. We're in the process of trying it. So for example, postpaid, we have this equation for postpaid. Total cost is equal to 291.80 plus 0.589699. The unit times units used. That's the equation for this. And then we have prepaid. Total cost is equal to 9.95525 over unit times units used. So let's try 710 units. Remember, this is trial. So we try using 710 units to find the point of intersection here. Like I said, my graphs are not that up to scale, so this point was supposed to be somewhere there. But yeah, let's pretend this is in between 700 and 800. That's what it's supposed to be. So we want to find the point of intersection. The point of intersection is when two graphs or two lines meet. Like here, this is the point of intersection of these two graphs. Okay, these are two graphs, two separate graphs, this and that. This is the point of intersection. The point of intersection is where both of them are equal. Okay, so let's try 710 units. Postpaid, total cost is equal to 291.80 plus 0.589699 times 710, which gives 17.4 cents. And prepaid, total cost is equal to 9.55425 times 710, which is equal to 706.47. Then we tried 750 units. Postpaid, total cost is equal to 291.80 plus 0.58969 times 715, which is equal to 703.3. Okay, same thing for prepaid. Also try 720. Same thing. So the thing here is try to find the point of intersection of these two graphs using trial and improvement, or with given equations. Okay, so here this is a constant. Okay, this is a constant. And then here it says unit times units used. Okay, it's unit times units used. So these are the units of electricity used. So you just try any. Like I said, this was supposed to be somewhere there in between 700 and 800. That's why we're taking values in between 700 and 800. 710, 715, 720. Trying every number to find the number closest to the point of intersection. That's the whole idea here. So all you do is use these equations. And do like I've done here, try 710 units and so forth and so forth. So in the next video we'll be doing practice questions to understand this a little bit better. So that's the end of the video. Don't forget to like, share and subscribe, and also comment, guys. Don't be quiet. Comment if there's any problem or if there's any request from you guys. Just comment there down below.